This content is not designed for use as a medical reference to diagnose, treat, or prevent medical illnesses or trauma. If you have questions about the diagnosis, treatment, or prevention of a medical condition or illness, please consult your personal physician.
Hi everyone, I hope you're having a great day. In the next few lectures, we're going to continue examining disorders that are primarily diagnosed early in development. This lecture, and the one that follows, will focus on autism spectrum disorders. I'm going to refer to this spectrum of disorders as autism for short. And we'll also talk about Asperger's syndrome. As of 2013, Asperger's is no longer considered to be a standalone diagnosis, but rather it's included under the umbrella of autism. Here's what we'll be covering in today's lesson: the symptoms that characterize autism, how autism is diagnosed, why Asperger's syndrome is no longer considered a standalone diagnosis, what the incidence rate of autism is and whether it's on the rise, common comorbid diagnoses, presumed causes, and the science related to vaccinations and autism risk. In our next lesson, we'll cover research associated with the brain pathology underlying autism, savant abilities, which appear in only a certain percentage of individuals, and treatment options. All right, let's delve right in. Autism was first recognized as a neurodevelopmental disorder by Leo Kanner back in 1943. The Diagnostic and Statistical Manual of Mental Disorders, or DSM-5, outlines the criteria necessary to receive a diagnosis of an autism spectrum disorder. These criteria are based on two domains: social communication and restricted repetitive sensory motor behaviors. There are three subdomains under the first category of social communication. These include deficits in social emotional reciprocity, deficits in nonverbal communication, and deficits in developing, maintaining, and understanding relationships. Let's start with the first subdomain, deficits in social emotional reciprocity. This is defined as an abnormal social approach, failure to engage in normal back and forth conversation, and reduced sharing of interests, emotions, or affect. Some examples here include a lack of empathy for others, an inability to recognize one's own emotions and emotions expressed by others, a lack of desire to communicate with others, and looking through others as if they don't exist, feeling overwhelmed in social situations as well, late development of speech. In many cases, the first word is not spoken until between the ages of 2 and 3. Having echolalic speech, such as repeating the last part of a question or repeating commercial jingles or stock phrases. So the speech is not creative or spontaneous. A high-pitched voice with an unusual rhythm and intonation, sing-songy, for example, or monotonous. And trouble gauging personal space, so the appropriate distance between people. The second subdomain, deficits in nonverbal communication, is defined as poorly integrated verbal and nonverbal communication, abnormalities in eye contact and body language, and deficits in understanding the use of gestures. Some examples may include a lack of eye contact with others, absence of pleasure through the exchange of body language, a tendency to have a blank expression when not comfortable with their surroundings, and a misunderstanding of what facial expressions mean or how to appropriately use them. The third subdomain, deficits in developing, maintaining, and understanding relationships, include things like difficulty adjusting behavior to suit various social contexts, and difficulty sharing imaginative play or even making or retaining friends. As an example, a good friend of mine has a teenage son on the autism spectrum. He had a friend in the neighborhood for several months. One day, the friend made a comment that offended her son, and that was the end of the friendship. For individuals to be diagnosed with autism, they must exhibit evidence of impairment in all three of these subdomains. The second domain, restrictive, repetitive sensory motor behaviors, has 4 subdomains. The first one is stereotyped or repetitive motor movements, use of objects or speech. Examples here include things like lining objects up in rows or flipping objects, and engaging in self-stimulating behaviors like rocking, hand waving, arm flapping, spinning, toe walking, and head banging. Such behaviors are especially likely if the individual has moderate to severe levels of mental impairment. The second subdomain is insistence on sameness, inflexible adherence to routines, or ritualized patterns of verbal and nonverbal behavior. Examples include desiring sameness and resisting change, having obsessive rituals and adhering strictly to routines day after day, such as eating the same meals, wearing the same clothes, or taking the same route to school, and throwing temper tantrums when these routines are interrupted. The third subdomain is highly restricted fixed interests that are abnormal in intensity or focus. Examples here include an intense attachment to unusual objects, like a piece of string or magnets, focusing on one part of a toy, such as by spinning the wheels on a toy truck. For more cognitively advanced individuals with autism, focusing on train schedules, calendars, or particular patterns of numerical relationships. Or, like my great-nephew, hyper-focusing on a particular topic like facts about space. Finally, the fourth subdomain is hyperreactivity or hyporeactivity to sensory input or unusual interest in sensory aspects of the environment. Examples include indifference to pain or temperature, or an adverse response to specific sounds or textures. Individuals may easily become overwhelmed by external stimuli and have a desire to retreat inward. For individuals to be diagnosed with autism, they must, at a minimum, exhibit difficulty in 2 of these 4 subdomains. In addition, the individual's symptoms must be present in early development, and they must cause significant impairment in social, occupational, or other areas of functioning. Autism is believed to exist on a spectrum that varies from mild to severe. In fact, the DSM-5 includes a severity assessment scale as part of the diagnosis. This scale varies from 1 to 3, with a 1 indicating that minimal support is needed and a 3 indicating that very substantial support is needed. I've had a couple of college students who were on the autism spectrum. For example, I remember the first time I met Brett, a student in the honors program. At the time, I was the honors director on campus, and I was standing in the honors center talking one-on-one with another student. We were standing directly facing each other and were close in proximity. In the middle of our conversation, Brett walked up as if the other student did not even exist and started carrying on a conversation with me. Based on his behavior, I knew he most likely had autism. Another student, Sarah, took my research methods course. At the end of the semester, I scheduled group presentations. Sarah asked if her group could go first, as it would ease her anxiety. I agreed, but told her that her group needed to be ready to go right at the beginning of class because I had to fit in all of the presentations within that class period. On the day her group was going to present, she wasn't there at the beginning of class. I waited 5 minutes or so, but she didn't show. Her other group members told me to go ahead with another presentation, that they would present once she showed up. So another group started their presentation. About 5 minutes later, Sarah walked into the classroom, saw that another group was presenting and had a complete meltdown. She started crying and ran out of the classroom. These are just two examples of how some of the symptoms of autism may play out in a real-world environment. Obviously, both Brett and Sarah are very high functioning. In fact, both of them received college degrees and now have very successful careers. A variety of professionals can aid in the official diagnosis of autism spectrum disorders, including pediatricians, psychiatrists, and psychologists. Diagnoses are based on a combination of clinical observation using standardized diagnostic instruments and caregiver reports. Autism disorders can only be diagnosed based on behavior. There are no medical tests that can detect them. Among these disorders is Asperger's syndrome. Hans Asperger first identified the syndrome named after him in 1944, just 1 year after Kanner identified autism. His identification was based on 4 young patients who he described as having normal to high levels of intelligence, but who lacked social skills and had extremely narrow interests. He also noticed a tendency of the patients to be clumsy. Finally, none of these individuals appear to have experienced speech delays. Because some of these characteristics were slightly different from the ones noted for autism, Asperger's syndrome existed as a distinct diagnosis between the years of 1994 and 2013. In 2013, the DSM-5 folded the disorder under the bigger umbrella of the autism spectrum, and today it is considered a variant of high-functioning autism. So why the change? Advances in research had a lot to do with it. Although research studies did find some variability in the strengths and weaknesses between individuals diagnosed with Asperger's syndrome and individuals diagnosed with high-functioning levels of autism, the findings weren't consistent. In fact, many of the differences noted were quantitative rather than qualitative, and most of the differences were primarily noted in younger children, but not as much in older children or adults. In addition, biological differences between the two groups, measured via MRI scans, turned out to be inconclusive. Even though Asperger's syndrome is not considered an official diagnosis anymore, the term is still frequently used by healthcare providers, caregivers, and patients themselves, which is perfectly fine. It's just that the official term is now coded as an autism spectrum disorder for diagnostic and insurance purposes. It is now widely believed that autism casts a wide net. So there's a lot of heterogeneity between people who exhibit very different strengths and weaknesses and who need different levels of support and services. Every person with autism is very unique in this way. Here's what we know about the incidence rates of autism. Currently, about 2.2% of adults and 1.8% of children in the U.S. have autism, and it is known to occur across all racial, ethnic, and socioeconomic groups. Boys are 4 times more likely to be diagnosed than girls. Approximately 31% of individuals with autism have an intellectual disability. Their IQ is less than 70. 25% have a borderline IQ range from 71 to 85, and 44% have an average to above average IQ range, greater than 85. About 40% of autistic individuals are nonverbal. And here's what we know about comorbidities. 30 to 61% of individuals with autism also have a diagnosis of attention deficit hyperactivity disorder, or ADHD, which we'll discuss later in this course. 50% have one or more chronic sleep problems. 11 to 40% have an anxiety disorder. 7% of children and 26% of adults have depression. children with autism are 8 times more likely than children without autism to suffer from one or more chronic gastrointestinal disorders. And roughly 30% of individuals with autism have seizures. It seems like a lot of people these days know of someone who has autism. It's natural to therefore wonder whether autism cases are on the rise. If you look at the Centers for Disease Control, or CDC website, you can clearly see that the estimated prevalence rates for autism have changed over time. In 2004, the prevalence rate was 1 out of 166 children. In 2008, this rate changed from 1 to 125. In 2012, 1 in 88, 2016, 1 in 68, and in 2020, 1 in 54. Why? What's happening here? Is autism on the rise? Or are there other factors impacting these estimates? Many believe that increased awareness of the disorder and changing criteria most likely account for the bulk of the observed rise in prevalence rates. We know that diagnostic criteria have changed substantially over time. In many cases, these criteria have become broader, which would increase the number of individuals diagnosed with this disorder. For example, when autism was first discovered, only those with severe forms of the disorder were given a diagnosis. Today, the clinical diagnosis of autism includes a wide variety of individuals, including those who have relatively mild forms of the condition. As research teaches us more about autism, doctors pinpoint new ways to recognize it. Over time, we've developed more screening tools and educated teachers and parents about what signs and symptoms to look for. All of these things would increase the incidence rate of autism disorders. Biological factors may contribute to this observed rise in prevalence rates too, although we aren't certain about what those factors may be. Perhaps a rise in older people having children contributes to the rate, as the risk of autism increases with maternal and paternal age. We also know that children born prematurely have an increased risk of developing autism, and because more premature infants survive today than ever before, this might also contribute to the increased prevalence rate. Most likely, there are a number of factors involved in the rise of autism rates. What we don't want to do is simply jump to conclusions that have no data to support them. We need to rely on the scientific method to help us investigate this observation. And unfortunately, it will take a great deal of time and resources to design, conduct, analyze, publish, and replicate research findings to arrive at some answers. Back in the 1950s and 1960s, cold and aloof parents were identified as the cause of autism. I mean, can you even imagine that? Just think about how awful these parents must have felt, believing that they, in fact, caused their child to develop autism. It wasn't until 1977 that autism was even understood to be biological in origin. And even then, this conclusion was muddied by a single research article, now broadly discredited, that had an outsized impact on the public's perception of both autism and vaccines. Back in 1998, Andrew Wakefield and colleagues published a piece in the prestigious medical journal The Lancet, claiming that autism resulted from brain damage caused either by the MMR vaccine for preventing measles, mumps, and rubella, or by thimerosal, a vaccine preservative. These conclusions, which sent a wave of panic throughout the world, were based on the examination of just 12 children, 5 of whom were involved in a lawsuit against vaccine manufacturers prior to their participation in the study. Wakefield himself was stated to have received up to 55,000 British pounds to assist the lawsuit by finding evidence linking autism to the MMR vaccine. Sound shady? It was. In 2010, The Lancet formally retracted the article, admitting that several elements in the paper were incorrect. Wakefield and colleagues were found guilty of ethical violations and scientific misrepresentation. Scientists across the world conducted study after study after study in an attempt to replicate Wakefield's findings, and nobody could. There is no convincing scientific evidence to support the claims made by Wakefield and colleagues. In fact, the evidence refutes them. I cannot state this forcefully enough. Neither the MMR vaccine nor thimerosal lead to the development of autism. When I think of all of the parents out there who continue to believe Wakefield's original finding, even though it has been refuted time and time again, it makes me sad and angry. The harm to society that this one man has caused is undeniable. Children have died, infections have spread, and diseases that were once believed to be eradicated have returned due to this article. So what do scientists believe are some of the risk factors or causal agents of autism? You're going to hear me say this with nearly every disorder we talk about in this lecture series. It is a combination of both genetic and environmental factors. Researchers have examined multiple potential causes of autism, though some have more evidence to support them than others. What we do know is that autism most likely has multiple causes that occur in diverse combinations, and that the relationship between various genetic and environmental risk factors is dynamic. Scientists do believe that the vast majority of autism cases occurs prenatally, even if some of the behavioral signs are not evident until several years after birth. What's important to keep in mind as we review these factors is that just because someone is exposed to a risk factor does not mean they will develop autism, only that their risk of developing it increases. There is no single gene that accounts for autism. Currently, approximately 100 genes are known to confer risk, and 1,000 or more may eventually be identified. Different genes are associated with different aspects of autism. Some genes have been found on chromosomes 7 and 15, but many more are being investigated. If we examine the concordance rates for twins, we find that this rate is around 76% for identical or monozygotic twins, and about 16% for fraternal or dizygotic twins. One thing this tells us is that autism is not completely genetic. If it were, the concordance rates for identical twins would be 100%. This signifies that environmental risk factors also come into play here. But what are these factors? One factor that has been examined is maternal infection during pregnancy. Some infections, like the German measles or rubella virus, which was widespread in the early 1960s, have been historically shown to increase the risk of autism. However, effective vaccines have helped to eradicate this risk. Today's widely experienced infectious illnesses, such as influenza, show relatively little evidence of increasing the risk of autism. And it remains to be seen whether COVID-19 has any associated risks. A second factor relates to autoimmune disorders in the mother. When a woman with an autoimmune disorder is pregnant, she has antibodies circulating within her system, a potential prenatal environmental risk factor that increases a child's risk of autism by 34%. Some of the autoimmune disorders with associated risks include type 1 diabetes, rheumatoid arthritis, ulcerative colitis, celiac disease, and psoriasis, to name a few. But how could immune dysfunction in the mother affect autism risk in the child? One plausible mechanism is that maternal autoimmunity may influence brain development by means of a hostile uterine environment, or maybe even by negatively altering the child's autoimmunity through immunoglobulin G, which can pass through the blood-brain barrier. A second plausible mechanism is that there may be a transplacental pathway by which maternal autoantibodies are introduced into the fetal environment. A third risk factor has to do with drugs. In the 1950s, a potent sedative called thalidomide was given to pregnant women as a relief for nausea. There was evidence to support the idea that the ingestion of thalidomide during pregnancy increased autism risk. This drug was officially banned in 1961. More recently, concerns have been raised about valproic acid and selective serotonin reuptake inhibitors. Valproic acid was approved in the early 1960s and has been primarily prescribed for epilepsy and seizure control. A study by Rebecca Bromley and colleagues in 2013, tracking 415 children, found that 7.5% of those whose mothers took valproic acid while pregnant had a neurodevelopmental disorder, primarily some form of autism. Compare this to only 1.9% of the children born from non-epileptic mothers. Selective serotonin reuptake inhibitors, or SSRIs, are primarily prescribed to treat anxiety and depression. Several studies have shown that SSRI use during pregnancy is associated with an increased risk of autism. However, other research studies have shown that autism rates in children whose mothers took SSRIs during pregnancy were no different than rates seen in the children whose mothers discontinued using SSRIs or whose mothers had anxiety or depression but did not take any medication for it. These findings have led some investigators to speculate whether, in fact, it is the mere existence of anxiety and/or depression in the mother that is the actual risk factor for autism, rather than the SSRIs themselves. Further research is needed to disentangle these possibilities. What about environmental toxins? Exposure to toxins during conception and prenatal periods of development have been examined and range from air pollution to cigarette smoke to heavy metals and pesticides. The field is in its infancy, though, and many results are contradictory. The strongest evidence shows a link between air pollution and elevated autism risk, particularly during the third trimester. And keep in mind, though, that factors such as the types of pollution, time of exposure, and so on could influence an individual's risk. Moreover, just because someone might be exposed to pollution in no way suggests that they will develop autism. The final potential cause I want to mention is advanced parental age. Research suggests that both maternal and paternal age at time of birth, greater than or equal to 35 years, are associated with an increased risk of a child developing autism. Evidence also confirms a combined parental age effect, meaning the risk is highest when both parents are in the older age range. Moreover, the risk increases with increasing differences in parental ages. There's a lot to talk about when it comes to autism, and we've only really scratched the surface today. In our next lecture, we'll continue our discussion of autism by examining proposed underlying brain pathology, savant abilities, which appear in a certain percentage of individuals with autism, and treatment options. See you soon.